Urban tree decline is a ubiquitous phenomenon by which trees planted in urban areas grow more slowly and die more frequently than expected. The USDA Forest Service reports that urban trees reach maximum potential for environmental benefits after age 30, but the average lifespan of a downtown urban tree is less than 10 years. Understanding what causes urban trees to decline will likely be key in promoting tree health in urban environments, especially as cities get hotter. Trees in urban areas offer ecosystem services that promote human well-being. They cast shade to cool buildings, prevent soil erosion, scrub our air, sequester carbon, and add aesthetic value. Urban trees are subject to a whole suite of stressors that forest trees simply do not have to deal with. Two of the most important are increased temperatures and increased pest insect herbivory. We already know that urban trees growing in the hottest parts of the city experience greater herbivory from insect pests than trees growing in cooler parts of the city. So perhaps the key to healthy urban trees lies in making the urban forest cooler and more like a real forest. This is where urban forest fragments come in. What is an urban forest fragment, you ask? Think of that scrubby patch of trees and bushes at the end of your block, or the unkempt woodlot behind the basketball courts in your neighborhood park. Urban forest fragments are any unmanaged portion of the landscape that contains trees. Most people overlook them entirely, but they could actually be quite important as refugia for healthy trees within the hot urban mosaic. We wanted to know if trees growing in and around urban forest fragments are disassociated from the stressors, particularly pest abundance, that cause urban street tree decline. Enter the humble scale insect. Scales are tiny insects covered by a protective waxy shell that sucks sap from trees. They are extremely common and detrimental pests of urban trees. We measured scale insect abundance on urban street trees and trees growing in urban forest fragments. We found that scale insects were more than 4 times as abundant on planted street trees than on trees growing within the forest fragments. But what could have been driving this difference? Our first guess was biological control by natural enemies. There is much evidence to suggest that ecosystem services, such as pest control by natural enemies, increase with plant diversity and structural complexity of habitat. And certainly there is no place within the urban environment that is more structurally complex or ecologically diverse than a forest. So we deployed sentinel twigs infested with scale insects in forests and street trees and allowed them to be exposed to natural enemy activity for 2 weeks. Then we collected and dissected the scales to determine what percentage of them had been compromised by predation or parasitism. Here are some of the natural enemies that we saw. The results were surprising. Contrary to conventional wisdom, natural enemy activity was greater in street trees than forest trees. Even though natural enemies were more than twice as abundant in street trees, they're unable to regulate scale insect pests. More work needs to be done to tease apart what exactly is regulating pests in urban forest fragments, but early research suggests that fragments do indeed represent refugia from common pests in urban environments. This sets up an interesting question for urban landscape designers who might wish to employ forest fragments as green space. Because urban space is at a premium, it will be necessary to approximate the minimum fragment area needed to optimize tree health and ecosystem services, especially as hot cities get hotter due to climate change.